Keith, what did you get at the end of step 1?
For X.
Yeah, for X.
I have 9.498 times 10 to the minus 7.
9.18 times 10 to the minus 7?
498. 9.498.
498. 9.49 times 10 to the minus 7. This comes out to 6.
5.613.
Oh, 5.613.
Times 10 to the negative 8.
Okay, times 10 to the negative 8. Did it check out? It checks out? Good thing. Did you have to use the quadratic? Yeah, definitely have to use the quadratic on this one. Did you decide to go to step 2 or did you decide to skip step 2? Do step 2. This is small hydroxide concentration. Three minutes left. Did you finish step 2? Did you get much additional hydroxide?
For that, like, 1 times 10 to the minus 8.
So 10 to the minus 8, this is 10 to the minus 7, so you got about 10% more hydroxide?
That's the actual.
Oh, the actual, the total hydroxide?
You have to add them up.
Yeah, add them up and tell me what the total hydroxide comes out to.
Total hydroxide?
Yeah.
I got 1.98 times 10 to the minus 8.
1.98 times 10 to the minus 8. Total hydroxide? 1.9, that's like what times 10 to the minus 7? That's like 0.19 times 10 to the minus 7. Something's not quite right because if, you know, 9.6 times 10 to the minus 7? Okay, that sounds more like it, right? 9.6 times 10 to the minus 7 means we got a little bit of extra hydroxide. And so we would have to do step 2. Except one thing. This is technique number 2. You know, technique number 1 is stepwise if it works. But sometimes stepwise fails. Do you know why stepwise can fail? How can stepwise fail? Well, this is it. If step 2 changes the total hydroxide, because now if we plug in 9.6, what was it? 9.6 what?
9.6 times.
Give me one more digit. 9.6. 0. If we plug in 9.60, is this still at equilibrium? What does Le Chatelier's principle say? Le Chatelier's principle says that if you increase the concentration of the products, we expect a shift to the left. Well, 9.6, this is close to 9.5. Maybe it's all right, but what if there's a more significant change? You know? And if there's a more, like for example, if I did 10 to the minus 8 here, there would be a much more significant change here. Now with a significant change here, that means step 1 is no longer at equilibrium, which means we need to recalculate step 1, right? But if we recalculate step 1, then that screws up step 2. And we have this, we have this problem. And the problem cannot be solved using the stepwise method. We'll talk about it tomorrow.